Okay, this is question 7 on page 163 of the A-Level Chemistry for OCR textbook, and this is on the topic of equilibrium. So for question 7a, you're given an equilibrium equation where you've got N2O4 splitting into two NO2s. First thing it wants you to do is give the equation for Kc, the equilibrium constant, and so it's always the concentration of the products divided by the concentration of the reactants. Here, products NO2, reactants N2O4, but then the thing you've got to do, look for the coefficients that are given, and they become the powers in this equation. So there's two NO2s, so that's NO2 squared. There's no coefficient, so it's 1, so it's to the power of 1. Okay, second part of this question, it gives you a value for Kc, a value for N2O4, and it asks you to find the concentration of NO2. So the first thing I'm going to do is multiply both sides of the equation by the concentration of N2O4. So we get Kc N2O4 equals, now that would equal the concentration of NO2 squared, so I'm going to take square root there, and that's what we've got. Then it's just a case of plug in the values, so it's 5.0 times 10 to the minus 3 multiplied by 0.5, and the value that should hopefully pop out was 0.05. It's a concentration, so it's moles per decimeter cubed. Okay, question part B. You're given the equilibrium for the Haber process for nitrogen plus hydrogen making ammonia, and the first thing again is it wants Kc. So again it's going to be products over reactants. So I'm going to put the ammonia in on the top, and I'm going to put my nitrogen and my hydrogen on the bottom. Two ammonias to the power of 2, 1, so nothing doing here, and 3 for the H2. Then it gives you the values in the order that's not necessarily the most useful. Please be careful when you do questions like this. Make sure you don't just start putting the first value into the first place. Really make sure you put them in exactly where they're meant to go. I've seen so many needless marks dropped over the years. So the concentration of ammonia is 1.54. Going to square that, and then we're going to divide it by the nitrogen's concentration, and then by the concentration of hydrogen. Sorry for the small glitch there. Big shout out to Holly, because the answer to this is 7.74. Now what we're going to do is talk about the units. So they vary every time for Kc. It's not something that's got set or fixed units. What you've got to do is calculate it every single time, and it varies depending upon how many moles of products and reactants you've got. So what we do to start, there were 2 moles of ammonia, and it was therefore squared. So you do the units for concentration, moles per decimeter cubed, times moles per decimeter cubed, because it was squared. Down here you've got the units of concentration for nitrogen, moles per decimeter cubed, multiplied by those for the concentration of hydrogen, and then because that's cubed, we've got 1 for the nitrogen and then 3 for the hydrogen. You do some cancelling out, and what you're left with is 1 over moles per decimeter cubed times moles per decimeter cubed, which we can combine, and it'll be 1 over moles squared decimeters to the negative 6. My apologies, going off the bottom of the video there. And then what we really want to do at that point is to tidy this up. So you get moles to the minus 2, decimeters to the 6, and then the convention would be just to put the positive one first. There we go. Thank you very much.